Hey everybody, this is Mastering Physics for Electric Circuits, number 7, part D. And the problem talks about these three circles right here, and if you were going to correctly set this up, which could be an ammeter, which could be a voltmeter, and which could be a resistor. So one thing I want to do is take the circles out of this, just show regular circuit with a battery. That's our schematic for a diagram, positive and negative ends. And here is a resistor. And where could you put things to possibly measure them? Well, a voltmeter has got this little symbol. I'm a nerd, and I have a voltmeter downstairs. But it's got this number on it that tells you what you're reading, and then this little dial. We used it in class. And you could turn that, and there were little leads in here. One was black, it would come out, look like this. And you could put it on one end of a circuit, and the other was red. I do have a red pen, but it's locked in here. Will I be able to open it in time? Yes. And the other was red, and it kind of came out here and looked like this, and you'd put that somewhere. Well, in a schematic diagram, physicists get lazy, and they just draw this. They don't even include the black and the red. And the key is that it has to go over top of a resistor. In lab, we would draw this, and we had our little blue plastic box, which the resistor would be in. And you'd put it on one end of it and the other, and that would give you your potential difference. In our circuit, it needs to go over top of a resistor like that to be able to measure the potential before and the potential after. That way, if there's a potential drop of, say, 3 volts, you could measure it, the difference between this and this. What's actually going on in a voltmeter is it's got a resistance that it knows, say 1,000,000 ohms. And when you put it in here, you put it in parallel, and then some of the current goes through here, and it says, oh, you're getting 0.001 amps. It takes a little bit of current away from this, multiplies that by 1,000,000, and gives you a voltage. It just does Ohm's law, delta V equals I times R. And that tells you the difference in the potential between here and here. An ammeter is a little different. An ammeter, how we looked at them in class, has a little box with little knobs on here for positive and negative, and it would give you a reading in amps to some number. We went in one side and out the other. An ammeter on the schematic looks like this, because the current has to go through it. You need to actually know what is the current inside it so it flows through it. It moves a little magnet which forces the lever to go up or down. So in this symbol, in this one, we need, or to look at the resistor here, we need something connected in series to measure an ammeter, or to measure the current. Ammeters connect in series, while voltmeters connect in parallel. So, it turns out 2 has to be your ammeter. And then one of these 2 then is going to be the voltmeter. It could either be 1 that's the resistor, or 3 that's the resistor. Either way, the other one would be the voltmeter, measuring the difference in the potential before and after. So either of those will work if you're trying to set up an ammeter, a voltmeter, and a resistor so they all function in a circuit. You can't put the voltmeter there. It would block all the current from there because it's connected in series, and you want your voltmeter connected in parallel. And you can't connect your ammeter at these 2 points because it would short circuit. An ammeter has almost no resistance, and a voltmeter has almost infinite resistance. So, that's the solution there.